Oakley dokley, good evening heroes and heroines, and welcome back to Practising Programming in C, episode 220, where we're going to be doing the reorganisation of the projects and landmarks. One thing I just realised is that we will have to actually do the sync projects function after something, won't we? Like even after reorganizing something, I think we still want to go on and sync those projects, right? Because essentially a sync project is going to then recursively go into these people. If we don't do that, I reckon we will end up not actually... Basically, the problem could be, right, after reorganizing a project, we could also have conceivably had some reorganizations of the actual project that still exists happen, right, which we wouldn't have actually accounted for in this reorganized project. So I think we want to do that also. Probably, yeah, I'm not sure where it is actually. Maybe after the reorganized project's call. I mean, I guess it's if we've located, isn't it? If we've located, then we do it. We could also just initialize sync projects. Like if we just do, where would it be? If we just do that so that we've got that available to us, I think we should do our stuff and then go in and sync. Would that be right? Because we've got the projects. Maybe not actually, because we don't have the projects parent. So yeah, it might be more good, I think. What is this passing? Well, it is passing the C child, isn't it? And the S child, so it is passing the same dudes that we're passing down here. So yeah, maybe you can just do that. We, like I say, we don't care about the in syncness, so maybe we should just get rid of that, because we don't need to propagate that back up the callers, essentially. Yeah, let's just say that's how that works. Oops. And then we don't bother with this in sync garbage. Or that. Do not care. Oh yeah. So yes, where we see in sync. Just get rid of it. Don't return in sync. Yeah, do not care. Do not care. So then that basically means that reorganized projects interior. It's probably going to be actually after here, isn't it? After you fixed up the dudes, you actually then go in and sync. Right, we're talking about the child. Yeah, it's always just the child that you're talking about. But it does need to happen after you've actually fixed up the pointer. So yeah, let's just call that. Is that what it was called? Sync projects? Yeah. So here we go. Sync projects. It's taking the G, the C child. Yep, because that's just the same kind of a pointer. And the stored child. Right. And then that should get us back into the person. What's it conflicting? It's wanting a C. Oh right, yeah. Okay. So yeah, I think that should be what we need to have happen. So now what we're faced with here is this situation. We have accumulated our people. We've got the three project generations accumulations, right, for want of a better phrase. We've got the global accumulator, we've got the local accumulator, and we've got this accumulator. And these are represented over in here, right? So these are saying how many entries in each generation there are. According to the database. Okay. So this is according to the configuration. This is the stuff that's correct. We've got this and this. So I think that this is to do with the landmarks. Let's get us a bit closer to the actual place where we're going to do it. And first of all, let us first of all write out the projects block essentially. So it's that. So that was right to the parent, and then it declares the parent counts. We don't need to do that. We can just write out to the first child probably. Well, we'll see. Definitely need to start off with this though. Yeah, so just as another bit of an overview as to what's happening, we need to. Well, actually, let's get there. Let's do the dudes first. So we've got in the projects block, we've got this kind of like depth first representation of the tree. We want to write out to it's to the S child, isn't it? So it's the incoming guest child. Because I believe that we know everything is correct up to there, so let's try and do that. Right, so that's going to write out that much. It's going to put the bytes written out at the schild. Having done that, we then want to write out this, do we not? Right, so basically we need to find what comes after this. This child, yeah. I guess we could be entitled to just change that to be this. Okay, so the next person is going to be this is going to be the byte after this entire project. So having found that, we then want to write out from schild to this. Sorry, that's garbage. We want to write out from this to next, essentially. Yeah, we want to write. So that's going to be that little chunk. Then we want to write out from where do we write out this first person to? Right to the schild. And then we want to write from schild to this. And then we want to write from next to the end of the block, essentially. I mean, we could also just sort of say we could just say write out the asset, right? And then you go into your assets loop. Okay. So this is the first asset. We want to do that. Now the interesting thing about this is that you need to make sure that you're writing out from the right stuff. Suppose we could set the pointer, can't we? Just in advance. So we want to go from this to next. And then from schild to this, and then next to asset, which I've got there. So yeah, we need to watch it because the write from byte to pointer is going to assume that we're writing out everybody in the order that they occur. So we can't use that. We could have a write from pointer to pointer, which additionally takes the bytes written. Yeah, let's do that. So what does it need to take? It needs to take a file, doesn't it? It needs to take the pointers. And it wants to take the uint 64 bytes written. I think that should be reasonable. And it also needs to be like this. So let's just go and look at right from bytes. Let's have a look at this function. Just a second. So the byte is, so you got the bytes through buffer. Yeah, it's a different sort of spec. Yeah, so we probably need, let's just grab these dudes. We could also just write that function higher up, couldn't we? So yeah, whereas this was talking about bytes through buffer, this is talking about bytes written, which isn't the same thing. Okay, so you sort of need to be aware that those things are not the same, basically. I wonder what this could be. What were we talking about earlier? Oh, it's not going to be the actual function, is it? It's not going to be the right pointer to pointer. Here's a bit. Oh right, it's of course the GDP thing. Yeah. GDP. Please just come up with a better version of gross domestic product. GDP permits difference via. I'll tell you what. I'll check that out. I'm going to leave that open, but I'm going to check it out after I've done this. Right, from pointer to pointer. Cool. Yeah, you just need to be aware. Basically, let's say A and B are actually from and to. I think they should be voids, but let's just also so that we're not doing illegal pointer arithmetic on void stars. Let's just get ourselves some cars for these. So they're similar to this actually. And I guess technically, actually, we don't need to actually get these out separately because we can just cast them in line. So what we're talking about here. Bytes into, yeah, I mean it is just the same. This line is just the same, right? So that's where we're writing yeah, right, so that's from byte to the pointer. So the difference here, so essentially rather than using that plus bytes to buffer is essentially the same. I'd have to replace this with this particular value here. Right, so this byte actually. Yeah, this byte here is the ending byte. But we need to make sure that we're not using that, so it's kind of specified differently. To take away from, right? Bytes to write. Okay, and then you just increment the bytes to write. I think that's what you want. So this tries undeclared, is it? Yeah, right. Yeah, we did change that. And this is write from byte to pointer. Passing an incompatible pointer type. Really? So what was he supposed to take? A file. What is the meaning of byte from? Oh yeah, you need to pass the bytes, right? Yeah, gotcha. So byte from is so what I'm thinking of this is it's essentially you've got a buffer. The location is the start of the buffer, and you want to be writing. You want to write out from the start of the buffer plus some amount. So the bytes from is the plus some amount. That's what it's supposed to be, at least. Yeah, that is what that's supposed to be. Two is large, you can have abs the other way around, or the abs any way you want. Do we even have that? It's in standard lib. Yeah, I do use that, don't I? What is it supposed to do? Compute the absolute value of an integer. The absolute compute the absolute value of an integer, argument j. Evaluate algebraically. How did I do it? Byte from. F buffer location plus byte from. Do you just mean without the space? Like that? Plus from. Oh, right, you mean do this. Well, hang on a minute. So he's saying to compute byte from by doing is that right? So this is going to be an address plus from, isn't it? So it's going to be the address of f buffer.location plus the address of from. Oh, I think I know what you're saying. Yes, you have got the actual address. Yeah, so I'm not actually doing that, am I? So basically, you've got the address of this isn't an address, is it? The byte from is the integer difference of the from and the f buffer location. Oh shit! Actually, that's a good point. Yeah, if I'm writing from and to, who gives a shit about where it is in relation to the buffer location? Yeah, that's a very good point. Yeah. Yeah, that is a very good point actually. Yeah, who gives a shit? Right? Yeah. Now, it's kind of funny. Do I need to make a note here? Do I need to make a note here? That from and to must be in the same buffer. I mean, basically, I probably don't need to make a note because, like, if you're going to be passing a from and a to, if you want to be using this function at all, like, it's only sensible that you're going to be talking about two pointers that are within the same buffer, isn't it? Just notice I'm recording a macro there. Yeah, okay. So right from this to next, and you want, so, yeah, and then increment the byte. So funny that I was like, oh, that's a good point, actually. Yeah, just yeah, use that actual value. Yeah. So funny they're going all around the houses just doing that when it's just like, who cares? Yeah, I mean, yeah, you can do that, can't you, as well, actually? So, what was it? then bytes written at the end. Yeah, I don't really use fwrite an awful lot. Sorry, that's complete garbage. I guess I don't really use all its functionality, really, is what I'm saying. Because if you see, most of the time when I call fwrite, apart from right now, I don't even use the return value of it. Do you know what I mean? So it's just one of those things that I just haven't bothered to remember, actually. Haven't remembered that it actually returns the amount that it's written. And that is what it returns, isn't it? Number of items read or written. This number equals the number of bytes transferred only when size is 1. Right, yeah. Which it is in our case. If an error occurs. Right, yeah. That plus equals printf. Did I use it for the message thing? Remember the No. I could have done that, couldn't I? Like fprintf here. I could have just set the message length to be equal to the result of that fprintf. And there was an instance though where I did actually use that. Yeah, again, I don't bother to, do I? Yeah, I guess that's just not something I've been doing at all. But like this guy here, in the same way, you could just set that message length to be that. And for all that matter, we don't even need that message length at all, because you can just use the message dot length, can't you? Oh, except for the fact that you free the string. Yeah, I don't know. Let's just double check that I actually do that right. So we're taking the bytes written. I'm going to increment the bytes written by the 2 take the from. I'm going to write that much from up to 2. 1 time to the f handle. Yeah, I think that's right. So right from pointer to pointer, bytes written. So once you've written from this to next, from schild to this, and from next to asset, the byte should be still correct, right? In other words, even though we printed these guys out in different orders, if the byte should be the same value as it would have been if we'd have just done one call to write from byte to pointer, writing to the asset straight up. So if I'm not mistaken, we're actually writing that stuff out to the first asset, and then we're on with writing, doing the actual assets. I guess we could test this, couldn't we? Just to see if it's at all partially right. think now that we've done that, actually, this could potentially come in handy. Or maybe not. Because we're going to have to offset these landmark indices. The project indices for the landmarks. Yeah, let's just quickly review. So we're right for the start of the file to the child. Well, then keeping the child there, and we're writing out from this to the so we're writing out this net to the next, so it's just this, right? So we write that there, and then we write out from the S child to this, and then write to the next to the S. So yeah, I think we're writing everything. Take into consideration the API to also bytes consume written, so it can be used like principal. Right? Yeah, true. I mean, there's no harm in doing that, is there? I mean, now that we're going to be doing it. Yeah, I mean, now think about it. These are all just doing, these all are voids. Yeah, I think I like the idea of just passing the byte by its address. I mean, the alternative is just this, isn't it? That's what you're basically talking about. Also, I guess you could sort of say, this guy, you might not necessarily care about the byte. Right? Well, let's wait until we've actually got that use case, because we have got this use case now. So let's just stick with this. If it turns out that we want to use this kind of a function for a case where we don't care about the bytes written, we can cross that bridge when we come to it. Yeah, so we've got that. Should we just write the rest of the file out and just and then just take a look at the thing? Oh, you just passed the byte. Something like Yeah. Yeah, I kind of thought you did. Yeah, and I suppose that'd give you F rights failures, wouldn't it? Also. Yeah, I think I might keep it as it is though. I mean, I'm letting it return the actual bytes written, but I think I'll let it continue to take the byte. I think I am preferring this way. I guess because it just gives you less stuff to think about. Like, you don't need to think about what you're doing with the byte, really. You just know that you need to take a byte of some sort. And you don't need to do anything on the outside with it. Yeah, I think I will. Stick with that. Yeah. But I mean, if I'm in that case though, I would make it handle passing null, wouldn't I? So you can just pass null like that. Result is equal to true and break. Yeah, I think after this, you just close, right? Well, cycle. And then I think the outer person will fix up the pointers for us. Down here. Yeah, they'll fix the pointers. And then we'll recurse in and sync them. So yeah, we're not handling the assets. All we're doing is making sure that these guys get outputs in the right order. So let's quit. Doing this child, this next to this, and then child next. Child this. No, I'm not. Am I? No, I'm writing from the start of the file to the child, to the first child. To the incoming child. And then I'm writing out from this to next. Sorry, wait. Yeah. So it's effectively this to next is just this, and then I'm writing out from the child to this, and then I'm writing out from the person after after this up to the first asset, and then I will be looping through the assets. Let's just check that I have done that right. So writing up to child, then write this, which yeah, I'm doing that. Yeah, next to this is something that I'm never going to be doing, because next is just the pointer. At least it should be, shouldn't it? Yeah, next is just the just reordering this child and this. Yeah. Oh wait, hang on a minute. Child this next to this child next. I see. Kind of read that totally wrong. Yeah, I effectively am, yeah. I guess one thing to be a bit aware of is that yeah, I think from the incoming this thing here, the incoming this S child to this this might not actually be a single project. It could be multiple projects. Does that make sense? And I think our test case is actually that very thing, isn't it? Yeah, should we step in? Let's step in and see what we're presented with. Right. So we need to get our people back in, right? Here we go, Bitwise and P are going back in. Wanted to remove this. Remove that. There's P, by the way. Children, yeah. So yeah, we've accumulated another person. Right. So you see we just skipped this. So basically this was the person after the incoming child, and then we just did this skip project and children to skip the actual other person. So there's two people in this. Or rather, this is 2 projects and their children after the incoming child. Yeah, when we get into there, we're not going to be able to actually see that stuff, are we? I don't think. So this is risky. That was bitwise. And next it's just going to be probably garbage, actually. It's probably going to be not a project. Yeah. Oh, it's just a car anyway. Yeah. So that's probably going to be the start of the assets block. Sorry. How do you do this? It's something like this, isn't it? Yeah. So there you go. You got ASET. So that's the start of the assets block. Right, which is perfectly fine, isn't it? What was that actually? That was this. Sorry, that was next, rather. Yeah, and then writing out next to the start of the assets block is, yeah, that should be legit. Let's take a look at the byte. Don't know if this is actually going to be particularly workoutable. Where children with more profit is one or more child. It probably would, yeah, but the thinking behind this one, S child, is simply that it's the stored child. At which we are currently located. You could sort of argue, couldn't you? And I think I probably would, that you would, well, I'll show you in the database. So you've got like the projects block here. If you're going to have a pointer to children, if you're going to call something children, I'd probably be wanting to be pointing to the first child, essentially. The first child of its parents. So this guy would be, so pointing here would be pointing to your children, but pointing somewhere. Well, here we've got an example. This would, you could point this to children, and you could similarly point to this to children, because this is actually a child of this person here. But saying that, because you're sort of sitting effectively here, right? Code is the child of this. It's the next sibling of intro to C. I think having a pointer called children for this, I don't just kind of feel too correct, because he's sort of denying this as being a child. If that makes sense. Yeah, I think I am understanding this okay. Do you know what I mean? Like, I mean, what you're basically talking about here, giving this the name children will kind of ease your ability to understand what's going on. You know, it'd communicate better to you what you're talking about. I think I do feel like I'm understanding S child to this to be an appropriate thing. If that makes sense. I do know what you mean though, but if it's one or more of child, linguistically, children would make sense. But yeah, I don't think that. I don't think the name S child is scuppering my ability to understand what's going on. I don't think. Should we have a look at where we're up to? We should be sitting at the actual. Let's have a look at the byte. So the byte is now there. 6.5. So we've done 3 more bytes. Is that right? Did I screw something up? 65740. So we did next. So we jumped past next. So having written up to S child. That reckons it's written out 3 more bytes. Yeah, I don't think that can be right, can it? It can understand without knowledge of. Ah, interesting. Yeah, so I guess you're talking about you want a context-free language is what you're kind of talking about here, isn't it? I think I want to step through this a bit again. Well, that's going to be a bit tough now because we've actually written out some stuff. Let's just let it write it. And just see what we're presented with. I don't think this should be right. Well, there's Ray. Sorry, it's Risky, isn't it? Who should come next. So yeah, we've got the handmade chat. And then we've got Risky. Book and co-ads. Yeah, and then Bitwise is coming through. And then we should have P after this person. Ah. Yeah, we fucked up. So Bitwise has been written out too many times. Yeah, I thought we hadn't incremented enough. There's P. Oh, there's Risky Business getting written again. So yeah, like I say, we definitely didn't increment far enough. So what is wrong there? Bytes written. We are dereferencing and incrementing that by the F right. from bytes to write, from 2 to from, right from pointer to pointer. Actually, I don't need to restart, I think. Yeah, this is what I want. Just run it again with a fresh thing. Comment these dudes out again. And run. I think we still got this breakpoint. Yeah. So, does it give me the support index? Let's step into each of these right from pointer to pointer calls. So in what world is 65740 plus 18112 65741, right? From is a void star. Does this need to be casted to a car star, maybe? Yeah, I mean, we can't really do that, can we? Not sure read the manual page correctly then. No, I understood that as you understood it. I mean, I might not be reading it right as well. Return the number of items read or written. Right. This number equals the number of bytes transferred only when size is 1, right, which is perfectly fine, because that's what we said. Oh shit, it's the number of bytes, right. Yeah, right, so that means when this size is 1, sorry, when this size is 1, right, so that's not what we want. Yeah, because basically, let's look at it again. F right, so the size is this, and the number of that size is this. This number equals the number of bytes transferred only when size is 1, when this size is 1, which it wasn't. Well, it's just what they're talking about, isn't it? So I've used this when writing out multiple landmarks. Right, they're the same size, so you set the size to be that, and you say you want to output this number of landmarks. I could, yeah, but I just don't like to do that. Like, I just understand this to be like one chunk of, I want to be writing out one chunk of this size. Do you know what I mean? Yeah, so it's just, that's the thing, isn't it? You just got to remember it's the number of those, whatever size of a thing that you're doing. Yeah, so that was the problem there. Let's reload. Remove the stuff. Still got the breakpoint, which is nice to see. So it's accumulated that. So let's step in again, I guess. I think we've got the breakpoint, haven't we? Yeah. We need to write that many bytes. That looks more like it. It's still returning the bytes to write. You just give size bytes. Multiply with chunk counts. How many array? Reference 1. Oh, really? C plus reference set is another thing. Array 0, reference 1. Oh shit, yeah. So what is it? C++.com. Okay. What's a word for make unsecure? Unsecurify reference. Oh, I need to run it. Bear with me. Getting a real peek behind the curtain here. I'm going to be revealing anything. Hang on a minute. Let me just... I don't want to reveal anything that I shouldn't be revealing, so let me just go to the Be Right Back screen. Just a sec. Alright, there we go. Sorted. Yeah, I think what there was is that I don't actually have I don't have Cinera running for the Ray project because it doesn't get updated very often. So I'm just perfectly fine just hopping in and just quickly running that when it needs to be updated. But for the regular Handmade Hero projects, I just let it just runs all the time. So yeah, bites to right. I think this is probably alright, isn't it? And then right to the end, and then cycling that file. So let's have a look at the file. We should have all of Handmade Hero, and then we should have Risky, shouldn't we? Yeah, we are. At least. This is what we had before. And then we've got Bitwise coming through. And then we should have P after Bitwise. Now, the $1 million question is, did we remember to comment out the thing from the config? Yeah, we did. Does the person who reported the thing expect an answer? I think Jesse is here. Jesse is right here, so... good point, there's no acknowledgement. Done it. Now, did you spot drop frames is at this number? I'm not sure if that's a continuation from the previous stream or whether it is drop frames from this stream. A bit troubling though. So yeah, that signposted file seemed to be correct. The you know, the project seemed to be correctly reorganized. We'll put in the drop this from frames. Damn. I wonder if there's anything going on with my ISP. Because usually I should be able to upload, like I'm below half the available capacity here. Usually it can upload at like 2000 kilobits per second. Sorry, this is kilobytes, isn't it? Or kibibytes. Yeah, my uploads rate is 20 megabits per second. And this is below half of what that would equate to, I think. So here we go. Doing this. Tell you what, I think we're within our rights to actually continue and look at sync projects. Well, actually, I probably want to be talking to somebody else, don't I? So the S child. So what are we looking at? We're now looking at risky. So yeah, we're then going in again and just ensuring that this is all actually synchronized up, which is fine with me. Isn't it? Well, yeah, of course it is, because this is the first child. This person up here is going to be the actual, what do you call it? The parent risky. Yeah, so that's right. Parent risky, and they have 3 children. So yeah, it's just essentially going in and synchronizing up all this stuff, right? And if it finds, well, let's just see what happens. Right, so that matches. So it's not going to try and reorganize that. Yeah, so we've found everyone. We should be returning now, shouldn't we? Yeah, so that's bang on. We did just pass a recursive call to sync projects, by the way, but I just let us go over it. Yeah, so we have located it. So S child at this point is like the risky top level guy. So when we skip, right? Yeah, we're doing the stuff here. Actually, we're going to be sitting at bitwise, who we've actually deleted from the thing. Now we've come to the end of the project count, have we not? Yeah, bang on. So now going to delete project at level, which is exactly right. Right, and then we're deleting and all that good stuff. How many times did we call delete project at level? Child project count. Three. That would have been 5, wouldn't it? Right. Basically, I think all that's just done there. It has also fixed up the landmarks, which are wrong at the moment. But what that should have done is delete bitwise and delete P. So let's see if it did do that. Yeah, it did. So there we go. That's working. So we must have, what that means is that we must have gone to a delete project top level twice. We must have called this twice, basically, to get rid of everyone. And now that there's one person in generation 0. No, that's not right, is it? Because there should be 2 people in generation 0. Yeah, I think that's right, isn't it? Like, somebody somewhere actually needs to accumulate that thing. Where's that happening? So there's the I'll just have a look in Vim actually. syncdb. So this person adds entity generation, and then it does sync projects. I think in reorganize, because that's like two different calls. I think when we do this, we just need to make sure that we call this to actually add that person to the generation before syncing. Does that sound reasonable? Then we should end up with this generation count being this entry count being 2 for generation 0. So let's just check if that's true first of all. Then we can go in and look at the actual stuff, the landmarks. Reorganize is the function that we want to be looking at. The interior. So yeah, okay, so the breakpoint is still correctly located. So let's remove the person. Oh, P's still sitting there. Wonder why that is. So they didn't want to get deleted. It's not at the moment, no. Mio's currently looking for employment, I think. So he's putting all of his effort into that. As far as I'm aware. We haven't hit that breakpoint, have we? No, we're just monitoring thingy. Oops. So there we go, counted that out. And hopefully we'll hit this. Yeah, perfect. So it's the it's the generations, wasn't it? There's that happening. Let's not bother to sync projects. But I would like to get through here. So what have we got? The project count should be 3, shouldn't it? Yeah, should be 2. Beg your pardon, because it's hero and risky. So the SI is currently 2. And what is the S parent count exactly? That's currently 4. Now, hero. Yeah, that is right, isn't it? Oh, yeah, you're not supposed to actually do this, are you? Yeah, this loop just needs to be while the product count in the config is less than the product count in here. Delete that product top level. Right, that's all you have to do. And this thing will decrement that product count. So that actually isn't the right loop. Because we're going to have this starting up here. When we do this first, we're going to actually, when this happens, this will get decremented. After having done this, we're going to increment this. So they're probably going to be even pass at some point. Pass each other. So that loop ain't going to cut the mustard. Where's that? 60p. Just need to be a bit careful of this. Yeah, I suppose it's saved off the deletion count, hasn't it? That's how this one could potentially work, whereas the other one couldn't. So I suppose you could argue that you actually loft this stuff out. Say loft it out, I mean just like picking it up like this. Yeah. So it's basically and then deletion index. I guess that would be a better way to do it. Yeah, it does, yeah. Oh, well. Yeah, it will do, yeah. It does conceive it. Yeah, so you're passing the same S child, basically. So you don't need to increment the child along. So this pointer actually remains at the same place, funnily enough. Yeah, let's just rerun now that we've changed that, just to make sure that that was right. We forgot to change the config. So I'm a bit conscious of the time here, by the way. It is 1:30, 2:30, 0:30, midnight. That's what we're looking at. We're looking to see if we can delete everyone. That's it. Right, here we go. Should be 2, shouldn't it? Let's just do it. Step right through. Let's just double check that S-child is actually looking kind of reasonable. It should be P, I think. Yeah. And hopefully those pointers have actually been fixed up. Yeah, apparently they have. So now we've got 2 people in generation 0, 8 in generation 1, 4 there and 4 there. I guess that sounds about right. So let's just take a gander at the thing. We should now see that P's gone. There's risky, which was previously have been below bitwise. The asset block is starting right there. So yeah, we've correctly done that stuff now. But what we haven't done is fix up the landmarks. So you can see that bitwise is still even existing. Although, am I looking at this right? Yeah, bitwise is existing. Did we remember to... Yeah, we did remember, didn't we? Because... Hold on. Should that have deleted the project? Sorry, they should have deleted the landmarks. I think it should have deleted the landmarks. Actually, I can just let it run, can't I? To the print asset landmarks function. It's possible that some of these could get screwed over. Like when you try and synchronize one of these projects, it could try and use the wrong landmarks. And how would that affect it? Yeah, surely it could be able to crash, basically. So it uses the wrong landmarks to point into the... to index into the project's thing. And then it could conceivably also have landmarks that are too far, that are further into the there's a number of bytes into a HTML file which are more bytes than that actual HTML file contains. So it could crash. Wouldn't be surprised if it could. Okay, so it didn't. But yeah, you can see the bitwise is still popping in there. 1.5. Basically, these guys need to be dealt with. The issue probably... Should we take a quick gander actually, just to see... Like, I'm fully expecting this to be broken, by the way. At least I would hope it is. Yeah, I mean, certainly risky should be, shouldn't it? Right? If we look at risky... Um, maybe we didn't actually use that. Let's just make it, let's just change to, I think we're in chat, aren't we? Because we still haven't done this, where we can actually set the right project. So we actually need to, every time we want to be working on a particular project, well, I say every time I need to be indexing something for Handmade Hero code or whatever, I actually need to manually set this because we haven't set that. So 1016 was the most recent one. If I just say that this category, what have we had? Little Brother, Future Son of Life Forms. Right, if I just do this, so it makes the topics thing get regenerated. Oh right, yeah. Oh shit, that wouldn't have even picked up. Hang on. Let's just let it continue. So there we go. So yeah, I think it might have just picked it up somewhere. It's got life form, doesn't it? There we go. Perfect. Invalid landmark, aborting update. Right. So somehow we handled that. That's what we need to fix tomorrow. Modifying and writing at the same time. Sadly, I am. Yeah. Yeah. So basically, in this delete prototype level, the way this is kind of working is that we're trying to synchronize up the database and the config. The database is in some state when we start, obviously, and the config is in a different state. When we encounter the reorganized projects, we are essentially we're basically you can think of it as shuffling up the desired project to its intended location, so it matches up with the config. So basically, as we go through the config, we make sure that we keep pushing people up to be in the right place. And then once we've got through the config, we might have some people to delete who have just got pushed down as a natural effect of having reorganized people. And then when we come into the delete project, we effectively we've got a pointer here. So we know that we need to, so that's the config, that's out of the window now. We're talking about the database. We've got a pointer for the child just sort of sitting there in our file. What we basically do is we just sit there with this pointer here, and the parent's pointer. So the parent's pointer is going to be somewhere there. The child pointer is going to be somewhere down there. And basically, while we've got people to delete, we just chuck them out of the window, basically. And then keep that pointer there, right? And then if there's another person to delete, they're just going to be naturally in that position as a result of having deleted the person that was originally there, if that makes sense. Modifying a flat database in a way. It is a flat database, yeah. It's a flat representation of a tree. Doesn't that ruin all the offsets of other things that show after those projects? Yeah, it does, yeah, which is what I need to fix up. The delete project is is fixing up the indices of those landmarks, but the reorganization isn't. Yeah, so that's what we need to actually do. You can see that happening in flags in one block in memory. Yeah, it is one block in memory. So delete project interior. Basically, it's this function here. Delete landmarks of projects and children. It's this area right down here. That somewhere. Yeah, so that's the line that is decrementing that index, the project index of the people later in the generation. But with just mirroring as much as the referred to material. Yeah. Yeah. It could even be worthwhile actually using the Wayback Machine, couldn't it? Because this is something that somebody who's been in touch with me does for their own website. They link to the actual source thing, and then they have a Wayback Machine link as well. Pass into memory, yeah. Yeah, I could do that. I'm not sure why I decided against it though. Um, yeah, I really don't know. Cannot remember what my thinking was, but that is something that has occurred to me to actually pass it in. So yeah, it's like you're saying, read the whole lot into memory. Fix the stuff up in memory, and then write it all out. Yeah, I cannot remember what my reasoning was. Yeah, I can't remember. Maybe I felt like the amount of work that the computer has to do could be less in the way that I'm doing it. I mean, I know it's not really particularly taxing stuff. Yeah, I mean, like the regular sync, like if it is in sync, you wouldn't necessarily need to do anything different, would you? You just see if they are in sync and then write them out. Sorry, see if they are in sync and skip them. So you don't need to write anything. But if you detect that you need to do some sort of a change, it's only at that point that you'd actually need to read into the read the stuff in. Yeah, do you have access to the Git? Where the hell is this? Well, I think I should be able to determine if you could do, because I might not. So this is for the oh, actually, yeah, you're not gonna get the sort of flatness from it, if you know what I mean. Because, well, I mean, it's going to be flat, but you're not going to get the idea that it's a flat representation of hierarchical stuff, because there is no hierarchical stuff in this version. I think DB4, yeah, DB4 is the current version. Well, that wasn't it. Good job, there wasn't anything sketchy in the old clipboard there, wasn't it? I was thinking about list things. Yeah. Yeah, some of this stuff actually is completely different. Oh yeah, have they got the +1s, by the way? Yeah, they have. Yeah, I don't know that this is really... This doesn't really describe the actual layout, really. Because there's no indication as to how the projects and the entries are sort of laid out. Or rather the entries of projects and the children of projects. I mean, I can just kind of talk you through it. Basically, you've got the main header, which is just going to be this. It's just the hex signature and the versions and the block count. And then, where is it? I basically straight up enforce that the first block is going to be the projects block. So we have that, and it's got a count, and the count is going to be a count of projects. So then, following this projects block little piece of information, we're going to have a projects header, and we have all its entries, right? So we have the header, and then you've got a number of entries, and the entries are these people here. And then after that, you then, if the project has any child projects, that's where their children go after their entries, after the entries of their own themselves. Right, so it's like header entries, and then if there's any children, it's like header of first child, entries of first child, and so on. It kind of goes on like that. So that's basically how the projects block is laid out. And then the assets block, you start off with the assets header, which is just this information. It's got the block ID, the number of assets in the assets block, and these bits of information, the root directory, root URL, etc. And then after that, you've got a number of assets, right? So you got your block header. You then got your DB asset for each, count of assets. You've got your asset, and then within each asset, you've got then your landmarks, right? And your landmarks are these things. So that's going to be project generation and project index, an entry index itself, and a position. So the position is the position into the HTML file of the actual landmark. So then within the assets block, it's just like asset, number of landmarks, and then just like asset, number of landmarks. Landmarks actually, no, projects don't point to assets. Projects, they just sit there themselves. So those are the guys that, yeah, they don't actually indicate anyone. It's actually the landmarks which are pointing, if you like, or indexing into the projects array. And landmarks are essentially they are associated with assets, but they're not assets themselves. They are just the positions into a HTML file where the hash of an asset occurs. So it's basically like this. It's just going to be pointing. It's like right here. So it's just like there's going to be a landmark for the hero code search page for the Cinera.css asset at this location. So whatever byte this is from the start of the HTML file, there's going to be a landmark that's pointing right at that C, right? Similarly for this guy, it's going to be a landmark that's pointing right at that D, and then right at the, and then for Cinera topics, right at the 0. And I make sure basically that all of these hashes are going to be 0 padded, so they're all going to be 8 bytes long, or 8 characters. So you can always rely on being able to output the hex value of those things. It's in such a way that they always fit the same 8 bytes, right? So basically, whenever you change one of these assets, I mean the most common one is changing the Cinera_topics. Whenever you change this, those landmarks are used to change this value, these 8 characters, in all of the entries that contain Cinera_topics. So that's the purpose of the landmarks. That's what they're referring to, and the way that they can actually do that without having to, they don't have to modify anything else in the file. They literally modify it. They just load in this HTML file, go to this point go to this byte in the file, and just straight up snipe those 8 characters into that file. Just check out the grasshopper correctly. How they relate in operations on theme and references. Okay. Take a look at the code when you find time. So let me walk you through one occurrence of the sniping in of the checksum. So basically what needed to happen here, the updating of the checksum. So you do your edit in here and you save the file, and where is it? Is it insert category? Is that what it is? Yeah. At least I think it is. Or was it build categories? There's somebody who figures out I think this is happening right here, isn't it? Yeah, okay, so here we go. It's happening right here. Concept of asset. Right, gotcha. So an asset, all an asset is a file. So yeah, our list of assets are just these guys. It's basically these files. So you can have an asset, a CSS asset, an image asset, and a JavaScript asset, and these are all just files like this. And they all have, the idea is that an asset is a thing that it's essentially, it's a thing that can be cached, really. Yeah, exactly. Yeah, it's a reference to that file. Yeah. So it's just a store of what this file's checksum is, along with all the other stuff that it needs. Well, that's just a regular old asset. We need to look at the DB asset to see what the database stores. So yeah, it's the hash, the type, the landmark count. So the type is used to get the location, because you got the file name here, which is only the file, like just this part of the file name. But to get the actual full path, according to what the config says, so the config, you can put this kind of stuff. So basically, it takes the asset's root dir, and it uses the type to add whatever you need. You know, this, whether it's a CSS path, the images path, JS path. Right, so it uses the type to build the full path of the actual thing. So yeah, that's essentially what an asset is. Yeah, basically, yeah. Well, I mean, it's strictly speaking, it's an asset. It's an index into the asset type names, strictly speaking. But we do use it to actually pull out these parts of the config. So I think if we look at the generate asset thingy, sorry, construct asset path. So this the constructing asset, asset path, uses that value, asset CSS, image, or JS, to pull out these bits of the config. I suppose it could actually, yeah. Yeah, I mean it kind of does, because you've got in the header, you do have the so you've got the 3 bits of information. You've got the root dir here, and then you've got the, oh shit, is this actually the same as it used to be? I think it is. Yeah, DB header assets is just the same in version 4.5. So yeah, it does contain the root dir in the database, and it contains, you store that, and that. Yeah, so I mean, we could conceivably, that function, that construct asset thingy, you could use a database. Yeah, you could use a database. Because this isn't, it's not project specific. The assets stuff is all global. So there's only one set, there's only one of these things in the database. So yeah, I mean, like I say, we do store that stuff. It's just that we don't use it directly from the database, I guess. Because we're using it here. And I think we just trust that the database has been synced up with the config, I reckon. If that makes sense. But yeah, here we go. So this function here, generate topic colors, gets called when the parser, or it's not actually the parser, it's just when the person who's responsible for building all this crap up encounters a category that isn't a medium, essentially. Is that right? Well, actually this even figures out if it's a medium. So yeah, it's just whenever it sees a category, which is one of these people, it comes in and it first of all finds out if this thing exists in the CSS, in the Cinera_topics.css file. Right, so it's doing a search somewhere here, probably. Don't know where. I think it's right there. So if it does find that person, then it What does it do? I think is it just known? I don't know. I mean, the high level overview is that if it finds that we know about this category, then it just uses the information. It uses the color information for that category where it needs to be. If it doesn't know about it, then it has to actually add that person to the file, which happens right here, doesn't it? Yeah, so f prints f to the handle. And then having done that, it does this update asset thing, right? And then after, so basically, when you add that stuff to the file, it changes its checksum. So I think, hopefully, somewhere that will happen. Yeah, that's going to happen here. String to Fletcher 32. Right, so this is what's going to happen here. It's going to set the hash of that asset file. And then it updates the asset in the DB. Okay. So we got all the, in the assets block, you've got all these assets. It's going to actually find that the desired asset, right? It's going to, blimey. I guess it's somewhere in here. It's going to try and find the actual asset. Right, locate asset is actually going to do the full thing, isn't it? It's going to try and find that actual asset. And if it finds it, then it goes into this thing here. It then sees if the checksum's different, I think, probably. And here's the snipe checksum into HTML function. So we've located the asset in the database. Yeah, it does check, doesn't it? Here, if the hash differs, right? So if the hash differs, it knows it needs to go into this process. It updates that hash, and then it just goes through all of the landmarks. Right? Say that we're looking at Cinera underscore topics. It's got itself to here. It just goes through all of these landmarks, indexing into the projects block. Where are we? Snapchat HTML for landmark index. Landmarks. This is the first landmark here. Yeah, right, locates the entry. Yeah. So it's using the landmarks project index and the landmarks entry index to actually kind of find that entry. Find that entry, read that entry into a buffer. Read the HTML file for that entry into a buffer. And then using the position of the landmark to write the checksum into those 8 bytes. Possibly. If the hash is not equal to the asset hash. It isn't if you only do operations with the hashed thing. Yeah, I mean the idea is that no, exactly. You don't have to do anything because the whole point of this is just to I mean that shouldn't actually happen, but I mean that's just a product of the hash not being good enough, isn't it? But I've kind of figured that the way that Fletcher fails, I don't think we should actually hit that failure. And I do want to replace it anyway. But yeah, if the asset if the hash yeah if the hash doesn't change, there's nothing to be done here because all it's doing, having gone through this process, is literally just changing this value to be the new hash. So that's kind of the point of it. I mean, I think the whole assets block could just go away. Like, possibly, is that true? Or at least the idea of landmarks. Maybe the assets block itself would have to still store the actual assets and the hashes, so you could compare a new hash against an old one across runs. But the landmarks could be dispensed with. Basically, you could get rid of the landmarks and just sort of say every time you need to every time this hash differs, you need to locate. You need to somehow locate, like search through the fucking file, and say, yeah, I just don't know what it would be. It'd be like something that's kind of reliable, reasonably reliable. You just got to search through the files to find where this value might be, and then write the thing in. So the way that they're used for basically caching. So when you go to the site, when you go to this page here, you should find that it'll download something. So we've got that. So you can see the hashes down there for some reason. Not 100% sure what that would be for. What's that say? Why can't I? Main dot. Oh, it's main.css. Yeah, so there is a hash. There is an asset for main.css as well, actually. I'm not 100% sure why we're not seeing one for topics there, by the way. So yeah, disable cache is there. So basically you should see that if you don't disable the cache, these guys just don't bother getting downloaded. Yeah, and they don't, because they're not modified. So that's all it is. These guys are just used to save it having to download it. That's it. I mean, a place where you compare hashes, and if they match, you compare assets themselves. If the hashes match, you compare assets themselves. Yeah, I don't think that I actually do that. If the hashes match, go on and compare the assets themselves. Yeah, I don't do that. And I guess the place where the hashes is used out here is, I think it's just when the browser sends the request, because basically what happens is it reads the file in, it receives the HTML file, I think, doesn't it? Somewhere probably. Where's the HTML file? Is it that? It reads the thing in, and the browser will have a store of these people, have a cache of the people. So basically it just uses this. Yeah. That's exactly what happens, yeah. Yeah, I don't think it even issues, because if it determines that the file is not modified from the file name. Oh, also, you got to remember that on the actual server itself, you actually need to say you need to put this into a directory, put this into a directory that is actually treated as being cached. So there's that part to it as well. So how does that happen? Cache control, yeah. So I think for wherever this is located, you actually, on the server, you set the cache control header to be this. Right, so that makes it actually cache. The E tag is also used for something, but I don't produce that. That's produced automatically by the server. So it was last fetched then. Fetched kind of 51 really. It's math modified. You can't determine from the hash two things are the same. You can only determine the opposites. Well, how are you supposed to use hashing then? Sorry, you're supposed to use hashing to figure out if something differs, if two things differ. Well, I mean, the opposite of differing is not differing, isn't it? Sorry, you're saying you can only determine from a hash if things differ. Yeah, I could have done that. I could have said, yeah, there's different version numbers. Why didn't I do that? I think I didn't do that because you need to store it, don't you? I mean, I know that I mean, obviously you need to store the hash, but what I mean is you need to store the actual increase all the time. Yeah, you couldn't know across runs, could you? I think. So if you only store, so basically you need to make sure that this thing actually tracks differences across runs as well as within runs. You could conceivably just say whenever you do a new run, you always rehash, or rather you don't rehash, but you just always increment the version number of the assets. You could say that, couldn't you? Just in case it has changed. Yeah, and maybe that wouldn't be so bad because it's kind of rare that you actually need to relaunch. But the thing about hashing is that you can actually tell, well, at least I thought you could. You could tell whether something needs to be updated, or rather, if an asset differed, if an asset was changed since the program was last run. Set the counter to max hash of the current database. Yeah, I suppose. So if a single person, if while it's running a single asset needs to be incremented, then they do get incremented. And then the next time it runs, they just use we're doing operation as a new one. That's just really increasing. Yeah. Yeah, I didn't really want to have assets depending on the presence of other hashes assets, because that can happen. Like you can remove an asset. I mean, we should see it tomorrow when we actually do the rest of the reorganization. We should see that the bitwise hash, the bitwise asset, should get deleted because there won't be any more landmarks associated with it. So that should disappear. And yeah, I guess about the... So if you're just incrementing the number, I mean, I do appreciate that I don't tend to actually delete the databases. Right, the data, whenever the database changes, it just if the format of the database needs to change, it just gets upgraded. So all the stuff is going to actually remain ordinarily, it'll just remain as it is. But if it happens that I have to delete the database for some nuclear reason, let us say that the database has been running for some time. We've had a few increments of the version number. and people have like different people have visited the site at different points along that journey, and they've got different versions of this file, different versions of whatever file. I suddenly come along and I'm like, shit, I've screwed up the database, I need to delete the database and restart. Might happen. It hasn't. I think it might have happened already. Actually, not many times, but just want to cover my back on that. But that might happen. Come along and say I've got to delete the database. So I delete the database and we start again from counter 0 or whatever. Now, different people have got different versions. So who's got the right version? In that situation, it's going to be the person who. Well, it's going to be the person who got the most recent one, won't it? Assuming that the asset wasn't changed since they downloaded it and since we reset. Sure, yeah. But what I'm saying is, if you're just doing a monotonically increasing thing, and different people have got different, they've downloaded this file. Say like this was r equals 0, r equals 1, r equals 2. Various people got different ones. Yeah, exactly. I don't think I could communicate that to them because I'm using the. Yeah, I think that's the crux of it. I can't communicate it to them. You just start at a big number. Yeah, but that's the thing though, isn't it? Like if you want to be talking about last index, you need to have that stored, don't you? And if you're starting at a big number, it's like, well, do you just kind of say that? I don't know, how do you kind of programmatically do that? I guess you could say that just every time the program runs, it just rolls the dice for a big number that the asset index starts at. Past last index is the least proof. I do think that was the problem though. Basically, you need the ability to communicate to people that something has changed. Because remember, this the where is it? The length of this thing is like this long. So what's that? Is that a year? Like this could conceivably, somebody could conceivably have downloaded something and be like sitting there with the wrong version of a thing for a whole year. So I don't know, you just have to kind of factor that kind of stuff in, I think, wouldn't you? If they've cached 0 to 12. Yeah, but how would I know that they've cached that? You know, if you're in that situation where you have changed the whole database, and you've deleted the database, you don't have that information, do you? So you basically end up in a situation where Well, actually, if somebody got version 0, I think it's like if somebody got versions, because you don't have that information, do you? You know where the last DB was at. Yeah, but what I'm saying is, if you've screwed up and you've had to delete the database, right? The database could have got completely mangled, so you can't get a reliable value out of it. Right? Using the hashes, it doesn't matter if you've scrambled up the whole database, because the hashes are independent of the database. So you can safely just wipe the slate clean and start afresh. And if the hash is the same as it used to be, then people can still cache it as they need to. Obviously can do. But if the asset has changed, then the people will all just get they'll get alerted to that fact. Yeah, exactly, yeah. I mean, at some point you've got to be able to use it in some way, haven't you? Yeah. And like I say, I do have it in the back of my mind that the Fletcher 32 hash does have a weakness, which is essentially that. Let's have a look. Fletcher. Right, so you're operating in essentially little blocks here. So it's blocks of 360, I think, is what it's operating in. If I understand right, the weakness of Fletcher 32 is that if two right, say that you've got a file that's 720 bytes long. Right, 360 times 2. So that you've got a file that's like that. You hash it, you produce a hash. Then you take that file and you swap the 360. You just swap the two halves. So you swap the two chunks of 360, and then rehash it again. I think it'll produce the same hash. Right. So that's essentially the weakness of Fletcher. Is that right? If a 16-bit block in the data word changes from that to that, the Fletcher data remains the same. Blocks of all zeros and blocks of all 1 bits. A sequence of all that's the same as a sequence of the same. Right, okay. If a 16-bit block in the data word changes from that to that, well, okay, so I totally didn't understand the weakness of that then. I guess it's this, is it? The shifting up of 16 is what it's talking about is returning that odd with C0. Well, that's talking about 16 bytes, isn't it? Sorry, no, it's talking about 16 bits. Yeah, so that's the weakness. 16-bit block. So that's 2 bytes. So if in the data word changes from that. Yeah, I don't know. At least I'm aware that there is actually there is a weakness at all of it. I guess one day I should actually just test it, test my understanding of it, and just give this guy some bytes and just see what it produces, and see how the weakness actually exhibits itself. But yeah, I think I figured that the hashes were a more safe way of doing it, kind of. I suppose a less stateful way of doing it is the way I'd say it, or the way I'd understand it. Whereas like the monotonically increasing version number is dependent on the state of the database. It's depending on the database actually being well formed all the time. Whereas the hash doesn't care about that. And I think it's better to err on the side of something having to be. It's better to err on the side of this hash changing. So it has to download again. Than the opposite way around. Yeah, which you kind of can't necessarily guarantee if you have to talk about the state. Yeah, I don't know. It's so long since I've thought about hashing, to be honest. You want a perfect solution to everything, always with the assumption that everything works. So this is one of your. Is this one of your non-negotiable clauses? It's got to be a perfect solution. This is a thing called landmark here. That's kind of funny. There's a leaf, a hammered ray. Oh, this is pretty sweet. So is this telling me that screen readers can't actually tell that there's a menu here that's under this stuff? I suppose that would make sense, wouldn't it? Because if it's reading the screen, it can only read that. When you get enough about it. Surely this has... Oh, it's just got 4 things, yeah. The tick and the static thing. Yeah, that's a good point. I can't actually do that, can I? Because it only opens when you're hovering. Where's this thing? Probably in the family, isn't it? So this is that. Right click when I'm hovering. Oh, I see. Yeah, I guess that's going back to here, isn't it? So yeah, it doesn't seem like it can see it. Is that true? Landmark. Oh, here we go. There's handmade. Oh, handmade ray. That's our current dude. Yeah, it just seems like it can't see it. That's unfortunate. I think I might have to try and figure out how to actually show the goddamn menu to people with screen readers. Because we can't have that, can we? Yeah, like people just go to the site and they're just like, well, nothing else exists. It's just the guy that I'm looking at. Anyway, how long have we been going? We've done another 3 hours. It's now 20 to 2 in the morning. Which means it must be 20 to 3 in the morning where you are, daughter. So yeah, I think I'm going to call it there. I'm getting pretty sleepy. Go and get some food, get some chillaxing time. I did links to this, didn't I, for you? Although it's old, but you can at least sort of have a look. Have a look at that. Oh yeah, I need to read this, don't I, for the GDB thing. I think that was it, wasn't it? Yeah. Alright. So that's all. Thank you very much, Heroes and Heroines, for being here, for being beautiful and fantastic, and for inspecting your elements. Until next time. Yeah, what will we be doing next time, actually? I think we're just doing the assets, aren't we? We're doing the landmarks. Reorganise project interior. Yeah, the to do is this, isn't it? So it's don't do this. Right. Right, that's what we actually need to do. What's happening again? No idea how we got an E in there. But yeah, there we go. So, that's it. Farewell for now.